Hello, hi. Hello, students. You are in the fluid mechanics laboratory now for the course 2CE01, and along with the 3 hours lectures per week, we will be having a very good practical exposure in the fluid mechanics laboratory, as you might have done in the other courses also in the first year and as well as in the schools. We will be having some practical performance carried out based on the theories which we will be discussing in the theory class. So we are in the fluid mechanics laboratory, which is located in our C building at the ground floor, where on the first floor we are having production engineering department, and on the ground floor we are having, say, transportation engineering laboratory, and at the end in the corner we are having the fluid mechanics laboratory. We are having the photographs of some eminent personalities by Kaka, the founder of Vallabh Vidyanagar. We have the other researcher, Pelton. You must have heard about the turbines, Pelton turbines. So he is the inventor of that, and then Henry Darcy. He has also given one very important law related to the groundwater flow that you will come across in the higher level courses. And also Osborne Reynolds. Reynolds is a very famous and well-known hydraulician who had given many theories in related to the fluid flows through different conduits like that. So we have a good entry to that one, and now we are entering into the fluid mechanics laboratory. It is a very much advanced one, well maintained, and equipping a very good working experimental setups. See, we can have one latest addition to that one, open channel, just added to our fluid mechanics laboratory some 6 months before. We have procured this particular open channel in our laboratory, and that we will be using in the higher level course, that is at the 4th semester, where we will be having the advanced fluid mechanics studied under the title of the hydraulic engineering. We have many other experimental setups in the lab. One other rare addition to that is the rainfall simulator. More of that you will come across in the course of the hydrology and water resources engineering. So that part we are having. This is a very rare equipment available at the state level colleges. Some IITs in our country are having this type of the facility, which we have added under the TICWIT project. So you will be exposed to these also at the later stage. In this particular course, we are not going to use this particular experimental setup, but the basic things, the basic fluid mechanics experiments we will be taking up, because fluid mechanics course is a very basic course related to the analysis and behavior of the fluid flows in the pipe as well as in the open channels. And this particular experimental setup we are having, we call it as hydraulic bench. Hydraulic bench is a common facility available to perform more than one experiment on the same one. We will be having underside. In the lower side of that, we are having some water tanks and a pump also, and an electric motor supplying and continuously rotating the water for supplying to different experimental setups. Depending upon the kind of the experiment that we have to perform, we will change these particular attachments. So these attachments are changed. This common hydraulic bench remain the same. We can have some 4, 5, 6 experiments done on the same setup. So this is how we are doing. One of that we are having, we will take up at the later part of the semester, where we will be having, say, the orifice. Orifice is one particular opening in the tank. This is a water tank that we will be using, and the flow will be coming out of that one, and how how much is the flow per unit time, that may be per second, per minute or so, that is coming out of the tank, that we have to analyze. So this is one experimental setup. Many of them can be attached to that one. We are having some of them lying on this platform, where we are having, say, the venturimeter and orifice meter. Venturimeter and orifice meter, they will be used to measure the discharge through the pipes. So this is the pipe, and a meter called venturimeter is attached to this one. And when we will be attaching these to some measuring device, what we call manometer, we will be getting how much is the flow in the sense, how much is the volume of the fluid flowing per unit time through this pipe, and that we can estimate. It is just like measurement of the petrol. So if we go to the petrol pump, we have to get some petrol filled in our vehicle, and for that we have to pay some amount to that one. So whether it is 1 liter, 1.5 liter or 2 liter or 5 liter petrol, that we have to measure, and it is done automatically. That is also a measurement of the fluid, a must, but we are not able to see it because it is all covered, but it is also one kind of the meter. Like that, if we have to supply water or some other liquid, we have to measure it, that how much is the volume flowing per unit time, and the volume of the fluid flowing per unit time, we call it as discharge. So discharge is one very important term that we are using in the fluid mechanics. We will come to make use of that particular term again and again in our discussions during the theory class as well as in the practicals. The other experimental setup we are having is the measurement of the losses passing through the pipes of different kind. Depending upon the material of the pipe, we may be having some amount of the energy loss taking place while the flow is passing through a pipe of, say, copper material, stainless steel, or say the aluminium or some other material. Kind of varying sections, the diameter, whether diameter is more or diameter is less, the amount of the energy loss will again be different. So we have to estimate what amount of the energy loss takes place while the flow passes through a pipe. We have to make use of this type of the experimental setup, and that can be attached to a very large scale. If we are having, say, some raw oil taken out of the ground by, say, ONGC or some other oil company, and that oil is to be transported to some refinery, say Jamnagar or somewhere, which is 400, 500 kilometers away from the source well, we have to pump it, allow it to flow in the pipe and send it to the refinery. So for that, what is the amount of the energy loss taking place, we have to find out, and based on that we have to arrange some pumping systems. Along this 400, 500 kilometer long pipe, we have to have the provision of some pumping stations. At every 50 kilometer or so, we need to have some pumping stations so that the oil is pushed forward. Otherwise, after reaching to certain location, the oil will not flow forward. And for that, this type of the experimental setups are very much important. So we will be performing this type of the experimental setup in our laboratory. There are some other experimental setups within the other hall. We are having a very large hall which houses many gigantic hydraulic machines. You might have heard about the turbines. The different turbines include first year course, basic mechanical engineering or so. You might have come across the different turbines and the pumps and like that. So the turbines are also studied in some other courses where we have to perform the experiments, that how much is the energy put into the system, how much is the energy coming out of the system, and based on that the efficiency, the term we call it as the efficiency of the machine, we arrive at. So these type of the experimental setups are housed in the other hall of our fluid mechanics laboratory. Of course, it appears to be little old one, but the experimental setups are very good, and we are able to understand the working of these different machines. So we will just now enter into the other hall where we are housing some other experimental setups also.